What's going on, everybody? The networking guru here with Trepa Technologies, and today we're going to finish up domain 5.2 of our Network Plus full and free course. If you like this content, make sure you like, subscribe, share with your friends. Let's go ahead and get started. So I'm going to zoom my face out of here. As much as I'd love to talk on the screen the whole time, that's not what we're here for. So today we're going to be going over domain 5.2.3, troubleshoot common cabling in physical interfaces, hardware issues. So our hardware issues, we're going to be going over PoE and transceivers. Pretty short section here, but very important when it comes to troubleshooting the network. First thing we're going to talk about is PoE. Now before we go over what can go wrong with PoE, let's talk about what it is. So this is using our standard Ethernet copper cabling, shielded, unshielded, twisted pair, our Cat5e, our Cat6a, Cat7, to actually give power, wattage, to power a device via that network Ethernet cable. So typically you see this is actually my actual office little rack I got here, because it's just me and I got some cameras, an access point. But you can see here, I have an access point and 4 security cameras getting power from my Cat5 cables, okay? So PoE is that standard. It's the actual IEEE standard that defines how we deliver power over that Cat5 cables, shielded, unshielded, twisted pair. So then what's the issues with that? So we have a couple. One, if you're not crimping your cables correctly. Like, we can have an issue where you could pass data, but you can't pass power because maybe one of the pairs, like pair 7 and 8, which is usually brown, white, brown, right? When we actually create a crimp a cable, make a cable, RJ45 cable, maybe that's not actually at the end, right? It's not aligned. So maybe we can't deliver power. Really, though, what we're looking at here with PoE is the most common issue is, do we have enough power? Does our hardware meet our requirements when it comes to power? So what are we talking about here? So we have PoE standards. So we have the 3 standards over here. Now, here's the IEEE for it, right? What we're going to call it is PoE, PoE Plus, or PoE Plus Plus, or 4PPoE. So network switches, when you buy them from the vendor, they're going to come with different power standards, different quality, and obviously the more robust a switch you have, if it's PoE++, the more wattage you're going to be able to supply at an individual level, and there's going to be a total power consumption as well. So with PoE, that's 14.4 watts. So when you go set up like a CCNA lab and you buy old Catalyst like 3000 switches or like 3800 switches, what was the old 3500 series switches? Those probably have the PoE, just a PoE standard, and maybe not all the ports. Maybe it's just the first 12 ports of PoE. And then as we upgrade, obviously, right, from our access to the top of the line, our bottom of the line access switches to the top line access switches, we're going to get the higher PoE standards, PoE++, and we're going to get the more total wattage. Now with that, obviously there's more consumption on the power bill. So like my 48-port catalyst switch here has 2 battery power bricks in the back, where maybe if I had a 24-port Catalyst 9200, I'd only have 1 power in the back, right? What I'm going to do here, too, is I'm going to expand this video and actually bring my camera down to show you this switch. But, yeah, there's just different standards, okay? Now, I don't know on the exam if you got to memorize the exact standards and what it supports up to, okay? But what I'm going to do here is I'm going to show you my switch, show you where it says PoE on it and how you would look that up. Or if you want to just look from the front, like, oh, this is PoE++, or this is UPoE, because that's what it's going to say on this switch, what it is, right? And where you can find that on this new Catalyst series. So I'm going to pause the video. Let me expand it. I'll meet you down at my switch. All right, so this is our 48-port switch here. You can see it says Catalyst 9300, 48 UPoE. So that's pretty much just saying, hey, this is a PoE switch. You can see it right there. We have our Ubiquity router up here. Now this doesn't, now maybe the other Ubiquity routers can tell you right here, but this one does not have PoE. So I cannot plug in a VoIP camera VTC machine that's powered over PoE into this Ubiquity router. Hence the reason why I need this PoE switch. Over here on the right, you can see transceivers here. This is where we plug in an SFP port. That's to plug in like fiber connections. And on the switch, we also have one here, a little network module 4-port SFP port. That's going to come up later on in this section. But yes, this is our Catalyst 9300 switch. That is PoE. We can tell from this port here, and it's 48. So sometimes we'd have switches where maybe the first 24 be PoE and the rest aren't, kind of in these older models. This one, all of them can deliver power. Okay, we're back. So you saw down there in the actual switches in the Ubiquiti router how it doesn't have PoE. The Cisco switch does. It'll actually tell you on the front there. Now, if we want to go into the actual CLI and let's check our power, we can do that as well. So I'm going to open up my secure CRT. I'm going to move my face in here because I want to put this on social media. My Gen Z and millennials will understand if you're watching this YouTube video. So if I want to look at the power, we can do show power. And I think on other devices this would work, but you see on Cisco, it's called show power inline. Now, what we see here is the available wattage. So we can see how much we have total in the entire switch we can deliver. This is a 48 port switch, okay? So I'd have to divide this by 48. I guess we can do that, right? Let me bring my calculator in here. So at most, and then you're going to see the class max here on the individual interfaces. So that'll tell you too. But at most, right, 1835 divided by 48. If we had all these plugged in, right, that's the max per interface we could have if all were PoE. Now, we typically don't have that, right? We don't have one access switch using all 48 ports for the PoE. So individually, though, we can see that each interface can deliver a max of 60 watts. So that's PoE++, right? Down here, we can see I have my cameras plugged in here, but they're only utilizing 14.4, okay? So, what's another command can we make sure at what PoE level this is? Because it says max 60, but is this a true PoE switch? So another command we can do is show power inline, and we can do this. So it tells us right there. Show power information based on the IEEE 802.3 BT standard. Look at that. Is this did I get robbed? Is this not a real Cisco switch? Look how it's spelled standard. That is funny. But we can see that, right? We can see that it is doing our device model or mode, is saying, yes, we can deliver that much. We can deliver the 802.3 BT standard. Okay. Another thing I wanted to show you guys is how to test the cable diagnostics on a switch. So what do I mean by this? Remember I was telling you maybe we're getting data to a phone, but it's not powering up. But we just made the cable. We thought it was good. We didn't do a cable test on it, but we eyeballed it, right? Well, what we can do on these gigabit Ethernet switches, and pretty much, okay, the new Catalyst switch is what we can do, right? Cisco, I'm sure other vendors may have something similar. But what we can do here is we can actually do something called a cable diagnostics test. So if I want to do test cable diagnostics, TDR, interface gig 6/0/45, that's one of my active ports, right? It's actually a trunk port. It's going to run a test. It's called the time domain reflection, TDR. And it's going to tell us if all the pins are open or closed status, pretty much if our cable is crimped correctly end to end. It's pretty cool. So now that we did the test, let's do show cable diagnostics TDR, interface gig 6/0/45, and look at it. So you can actually see here, pair C, the pair status is open. Now, we can look up, right? We could look that up, what that means. But essentially that means that this pin, this pair C here, is not as complete or is not as, up to standard as the other ones. Well, more than likely, if I were to unplug this cable, I'd lose all my internet. But I'd probably see, right, is that pair C, which I don't know if that's like green, white, green, I can't remember, is probably just a little short of going all the way to the end. So I think this is pretty cool. Let's see. What's another gig 42? Let's do 42. And then we can show I might have froze my switch here. That's okay. All right. I'm going to pause the video while this unfreezes. Okay, we're back. Switch was just frozen there for a little bit. And now if we do show cable diagnostics, TDR, interface gig 6/42. We can see that's what we want. It's all normal there, okay? And we can see our speed is 1,000 megabytes. So in this one that is not correct, we have a open here, which pretty much means it's just not, if you've done like electrical, and I'm not an electrical engineer at all, but closed actually means that it's working on like a circuit. So open means it's open, right? It's not working. Look at our speed, only 100 megabits. So there we go, right? And that's just a trunk port to, actually, I looked at my network. That's a trunk port to a test switch I have in here, so it's all good. We don't need to worry about that cable. But think about this, though. Think about if we were on a local area network, and we notice our speeds just between, like, in our own LAN between VLANs is messed up. And that was the trunk port to our router that's supposed to be doing gigabit. Because we didn't encrypt something correctly, but it came up. I'm passing traffic, but I'm not getting my full gigabit speeds because one of the pairs is not working. So kind of crazy, right? This is a great way to test something, especially if you're remote. All right, back to our slides. So PoE, again, more definitions. Power budget exceeded. That's another hardware issue. Just we don't have enough power, right? Let me zoom my face back out. Next, let's go over transceivers. So transceivers, or SFPs, they're what they plug in. We'll have like transceivers on the actual switch itself. And then we have these different SFPs. That'll be for different multi-mode, single-mode fiber types, different connector types. And it's always one of the biggest problems with it is just a mismatched SFP for the cable type, okay? So in that video where I went up close and personal, you'd be plugging in an SFP to there, okay? So an example of a transceiver issue is a 10 gigabit per second SFP plus transceiver on one end of a connection paired with a 1 gigabit SFP transceiver on the other will cause a mismatch. And then we will have, packet loss. We won't be able to pass traffic at all. Maybe SFPs support different wavelengths, okay? So one wavelength will be 850 and the other is 1,310. That could also lead to a mismatch. So we just want to make sure we have the right SFP for the job and that before we go on site, that we do some testing before we're on site and we're like, man, I got to drive 30 minutes back to the home office and I got to grab a different SFP because this was not the switch I expected to be here. And I have multi-mode, and this is a single-mode SFP. And they're really hard to see, like, it's just little things right here. This one says SFP 10 gig. This one says SFP 1 gig. It's hard to read on there, right? I wish I could zoom in on that. I wish I had one physical. I'm in my office that doesn't have all my other hardware available to actually show you in the camera. It's hard to tell sometimes, right? So we just want to make sure that we're doing the proper research before we get on site, before we do installs, okay? All right, let's go ahead and do our quiz. Okay, so we're at our Academy site, our learning management system, custom made for Trepa Technology students. Let's go to our Network Plus course. We'll go to week 4. We're in domain 5.2.3. And let's go ahead and take our domain quiz. Let's zoom in here so we can actually read it. I'll put my face closer here because I know it helps you guys answer questions. I know it does. Come on. Question 1. A network technician notices that multiple IP phones powered through PoE are not functioning correctly and some devices intermittently lose power. The technician suspects a power budget issue. What is the best first step in troubleshooting the process? Just reboot that switch. I'm going to probably go with C here. Check the power requirements of each PoE device connected to the switch. We just got to check the power, right? Plan power for, and we need to add another switch. Maybe that's what we need to do, or upgrade the switch. So I'm going to go with C. Check the power requirements of each PoE device connected to the switch. Pause the video if you'd like to read our explanation. And all of our questions have this, guys. For all of our different courses, we teach questions with explanations, and you have unlimited times and tries. Question 2. A technician notices that a device using an SFP transceiver is only able to operate at 1 gigabits per second on one end, while the other end has a SFP plus transceiver capable of 10 gigabits per second. What could this mismatch lead to? So I'm going to go with B. The connection will fail or have intermittent connectivity issues. More than likely fail. There's the explanation. Pause the video if you'd like to read. Question 3. A technician connects a new security camera to an Ethernet switch using PoE. However, the camera fails to power on. What could be the cause of this issue? So it doesn't power on, right? So we're going to take a guess that it doesn't have enough wattage. And this happens a lot. So I have basic Ubiquiti bullet cameras that only require PoE, right? I don't know the IEEE standard off the top of my head. It's going to tell us the explanation. So only I need 14.4 watts. But if you have advanced cameras that go up and down, 360, have motor capability, like automatic, right? Like AI-enabled cameras now is what they're going to call it. You probably need those higher standards, 60 watts. So PoE++, right? So here we go, 802.3 AF, only 14.4, whereas 802.3 AT PoE Plus is up to 25.5. Question 4. What tool would be the most appropriate for checking the signal strength of a fiber optic connection? So, okay, we didn't actually talk about this, so this is cool. This is going to be not a cable tester, guys. It's actually going to be an optical power meter. So optical, that's like fiber optics, optical power meter, right? So here's the explanation down here. Pause the video if you'd like to read. Question 5. Which of the following issues could result from a transceiver mismatch on either end of a fiber connection? This is not PoE. If anyone discovers how to do PoE over fiber, I'll invest. I don't think it's possible. Well, maybe. I don't know. Anyways, it's going to be A, okay? We're talking fiber, nothing to do with PoE. And it's going to have intermittent connectivity or complete link failure. Pause the video if you'd like to read the explanation. Question 6, final question. Let's go. We're going to get 100. During a routine check, a technician discovers that signal strength on a fiber optic line is weakening. What is a common cause and solution for this issue? So it's not PoE. It's not network traffic. It's signal strength, right? It's not like necessarily... A short cable would not be the cause. Shorter cable would be better signal strength, less like attenuation, fiber, right? Well, A, long distance cable run, add a repeater or amplifier. And that could happen, I don't know, long kilometer distances. Maybe we have single mode fiber that needs an amplifier. Maybe it needs it. Maybe it's not those long standard runs that can go 70 kilometers, okay? So we'll pause the video if you'd like to read the explanation down here. Now let's view our results. 100%, let's go, baby. I want to thank everyone for viewing. If you like this content, like, subscribe, share with your friends. And if you want access to our academy, our learning management system, click that link in the description below, and let's get you certified. I'll see you in the next video.